Good morning or afternoon, everybody. Thank you for joining our webinar today. We'll get started at the top of the hour. But in the meantime, we just wanted to say hello, start letting people in. And if you're feeling a little chatty this morning, you got your coffee, go ahead and drop us a little chat, letting us know where you're at, where you're dialing in from today. Say hi to us. Uh, we're over in Monrovia, California, so near Los Angeles. That's where Parasoft is headquartered. It's turned out to be a beautiful day so far. Been getting some good weather, haven't we been, Ramiro?
Yeah, I was tired of 106. That was rough.
I know. We had it was 113 about a week and a half ago, so this nice cooling off is just perfect.
Yeah, it's been nice. Got a bit of shade.
Hmm.
Thankfully, not too close to the fires. So,
All right. Seeing quite a few people still joining, so we'll just give it another couple seconds here and then we'll dive right in. All right. Okay, well, it is that time, so we're going to get started because we do have a lot to cover today. Um, so again, good morning or afternoon, everyone, and thank you for joining today's webinar presentation on AI-enhanced API testing, a no-code approach to testing. My name is Jamie Motherall, and I'm a product marketing manager and functional testing specialist here at Parasoft. And on the line with us, we have one of my colleagues, Ramiro Martinez. Ramiro, you want to say hi?
sure. Hi, everyone. My name is Ramiro Martinez. I been here at Parasoft for over 8 years now. Started off on the support side where I assisted with technical questions that came up. Moved into professional services where I help customers reach their goals, their technical goals with special projects. And I'm a solution engineer at the moment. Nice to be here.
Ramiro's got a lot of years behind him in history working with our customers, working with our solutions. So he's going to be a great person to help us with today's presentation. And we do have a great presentation planned for you today. But before we dive in, we want to do some quick light housekeeping. If your view of the GoToWebinar screen is at all blurry, please be sure to adjust the resolution in your browser. That usually helps. And then in today's presentation, we plan on both discussing as far as going through some slides, as well as doing some technical demonstrations of examples of AI applied to API testing. So because we are doing technical demonstrations, we highly recommend setting your display to full screen. And then if you do have any technical issues with GoToWebinar, please go ahead and drop us a little message into the Q&A box. One of our members on the line is going to try to assist you, okay? All right, again, we have a lot to cover, so we're going to start off with reviewing our agenda. We're going to start by discussing the API testing landscape, API usage in modern software development today. And then we'll start discussing some of the common challenges that hinder an organization or QA team from adopting an API testing practice. From there, we're going to turn our focus on how AI can address these challenges. And we're going to show you two examples of how applying AI to API testing can accelerate test creation and make it easier for less technical teams to adopt and scale API testing. We're going to dive into a technical demo showing both a top-down approach for test creation, and this is all about enabling manual testers to generate API test cases from traffic recordings. Then we're also going to look at an example of generative AI, LLM, and how it can be leveraged to generate test cases. This is going to be very particularly useful in API-led development. From there, we'll start talking about our last topic, which is managing change. And we'll look at how AI can help teams to focus their test strategies on the parts of their application that have experienced changes. Then we'll do a little quick wrap up, dive into our Q&A to close out our session with you all. Now, keep in mind today's presentation and demo are high level, and that's really due to time constraints. If you are interested in taking a deeper dive into our AI solutions with Parasoft, I highly recommend requesting a demo with us. Of course, we have also allocated time at the end of today to address questions. But if you do have questions that pop up, feel free to put them into the Q&A box at any time. We're going to be monitoring the Q&A box as questions come in, and if it makes sense to address something in real time, because of the context of the presentation at that point, we will. But again, if your question's not answered in real time, we'll be making sure to address it at the end of today's presentation. We are going to turn off our cameras for the rest of the presentation because we're going to be doing those technical demos and it can be a little distracting. So we'll just turn that off and then we'll dive back in. All right. So, why are we talking about API testing in the first place? Well, more and more software is relying on APIs. And this information is from a study DevOps Digest did on API usage. So, 98% of enterprise leaders agree that APIs are an essential part of an organization's digital transformation. And that's because reliance on APIs really ensures for a smoother customer experience. It also can accelerate innovation, increase collaboration amongst development teams, and it enables more joint development with partners and third party teams, as well as improves the developer experience. So there's a lot of kind of benefits when it comes down to API usage overall. And there's a couple of factors that are really driving the growth of API usage today. So, digital transformation, companies are increasingly moving toward these digital platforms, which require seamless integrations between various systems, applications, and services. And APIs enable this interoperability, allowing businesses to integrate new technologies really without disrupting their existing systems. Um, Cloud computing, microservices, we've seen this adoption of cloud-based solutions and microservices architecture has really fueled the need for APIs. And that's because these architectures are relying on APIs to communicate between distributed services, making software systems more scalable, more modular. This one's kind of a no-brainer. Web application growth. We've all seen the explosion in growth for both mobile apps as well as browser-based applications, and that's also led to this greater reliance on APIs. These APIs frequently are needing to interact with backend servers, external services, and that's all facilitated through the APIs. Of course, on the business side, you always want to think about agility and faster time to market. On the agility side, you want to make sure that your releases are meeting the needs of your customers. As you get more information, you may want to be able to pivot. And then on the side of faster time to market, it's a competitive world out there. So you want to make sure that you're able to get your software to market faster, get ahead of the competition. And APIs really allow teams to leverage existing services and tools rather than having to build everything from scratch. So, overall, that accelerates development, it leads to faster product releases and updates. It's also kind of driven this rise in APIs, how much APIs have become more dependent in the industry. Third party integrations and ecosystem development. As business partners, businesses start to partner with other companies or incorporate third-party tools. So, example like a payment gateway or analytical tools, APIs are serving as that conduit to integrate these external services smoothly. And many companies are also starting to build ecosystems around their products. So, take for example, Apple, Google, Facebook. They're encouraging third party developers to create integrations using their APIs. And this has also led to this explosion in public and private APIs. And then the last one is user experience and data driven applications. APIs are really critical for delivering a personalized experience. And if you are in the e commerce or entertainment or social platform industries, user data from various sources must be integrated in real time. So modern applications are increasingly relying on these large data sets, and APIs are facilitating access to this real-time data from multiple sources, enabling more dynamic and data-driven software, which in turn is allowing a more personalized user experience, so increasing that user experience for your software. And it's not only that we see that API usage is growing, but also the maturity level of APIs and how they're being used is changing. while process or system APIs are very standard, we are seeing this growth in experience APIs or browser-based APIs. So the APIs that your end users directly interact with under the hood of your UI. And we also see this rise in public APIs for the revenue generation. So however, even with this growth of API usage and the rise of these experience, browser-based, and public APIs, many testing teams are still unfortunately heavily relying on web UI testing instead of validating functionality at the API layers. We're all probably familiar with the testing pyramid, maybe a little tired of it, but at its core, it's really designed to give teams a blueprint for how to build a scalable test automation strategy. And unfortunately, we often see pyramids that look more like a goblet where API testing is skipped and the majority of testing occurs on the UI layers. And that tends to be because web UI testing tends to be more straightforward for a less technical tester. UI tests are very quick to define, but at the end of the day, they take a long time to execute. They do require a complex test environment. Keeping tests updated and maintained when the UI changes a lot, that also then adds a lot of scaling challenges when it comes to your test automation. And this is one reason why Parasoft really recommends what we call a lean web UI testing strategy, which simply encourages testers to prioritize API testing for validating functionality. Now, of course, web UI testing still is important. It has its place, and it's a very important part of ensuring a high quality user experience. But by testing the APIs in comparison to web UI testing, there's a number of benefits, and it makes it a much more ideal for scaling test automation. So API tests are quick to execute. They provide faster feedback during testing. They don't require a complex test environment. They're easy to automate. All of this means that API testing is more scalable, maintainable, and facilitates higher levels of test automation. So if API usage is increasing, then why are teams still relying heavily on the UI or end-to-end testing to validate functionality versus directly testing the APIs? We often hear the common roadblocks to adopt API testing are associated with test creation. So we hear, it's hard to create API test. It's difficult. It's manual. It's time consuming. And when you think about, creating an API test from scratch where you're actually writing it yourself, there's a lot of scripting involved. You're doing request response pairings. If you're trying to do an API scenario test, it can be very complicated and very time consuming. We also see that testers don't really understand what the APIs are doing. So they don't understand the user stories and requirements for API testing scenarios, and they find it very difficult to define them. And all of this really results in an assumption that API testing requires technical or development level expertise. So oftentimes a big roadblock for a QA team looking to adopt API testing is going to be the staff members that they have. Do they have the right staff in place to adopt and support an API testing practice? And that's really where AI comes in to help us kind of solve some of these challenges. Now, there's three different examples of AI that we're going to either be demoing or discussing in today's presentation. So the first, we'll look at how AI and ML-based test generation, in which API test cases are generated from a traffic recording. And we're going to talk about how this helps less technical teams more easily adopt their API testing practices. Then we're going to look at an example of generative AI-based test generation. So we'll demo how Parasoft has incorporated LLM into its solutions to help teams more easily generate API test cases in API-led development. From there, we'll start discussing change management. So we're going to look at how AI-based solutions like test impact analysis can help teams to focus their testing efforts on the parts of their application that have experienced change. If time allows, we'll also briefly discuss how Parasoft enables easy test maintenance. Though please note, that's not an AI feature, but rather just a nice way to wrap up our discussion around change management. So I think that's enough for me. I'm going to turn it on over to Ramiro. He's going to set the stage for us and dive into some of these technical presentations. So Ramiro, give me just a minute and I'm going to change you on over as to the presenter.
All right. Thank you, Jamie.
All right. You should be set to go.
All right. All right, hopefully everyone can see my screen now. So traditionally, when testing through the UI, you're not thinking about the APIs, about how the APIs work and how they're used. The UI already has that business logic built in, and it's extracting those details, orchestrating the sequence of API calls necessary to fulfill the needs of the UI flow. But when testers need to write API tests against the system directly, they don't know that business logic that the front end is using. So what we do with Parasoft is we capture that network traffic while extracting the UI, and our AI builds a model of which stateful data needs to be extracted and parameterized so that the sequence of generated API tests will faithfully execute the business logic defined by the user's interface flow. So we're automatically generating API tests that perform the functions and workflows typically tested through the UI, and then running them without the UI. All right, so enough slides. Let's kind of just get into this. So we're gonna bring some things up. So smart, and this this feature is called Smart API test generation. There's two portions to this. The first one is going to be on your browser. So we have up here on the top right this Parasoft Recorder plugin that's for Chrome. And what it allows us to do is any actions that are now performed, once I have it enabled on the web page that trigger API calls, is going to, we're going to capture those API calls. We're going to create a traffic file for it, and then we're going to send it over to SOA Test, which is our API testing tool, which is going to handle the second portion of this solution, which is actually taking that traffic, parsing through it, looking for important information, making extractions, making parameterizations, making assertions, and then generating that API test for us. So I have a recording going. So I'm going to log in. When I log in, API tests are triggered, and we're going to be capturing all of that. The website we're working with today is Parasoft Demo App. It's a website for allocating resources to locations. This version of it is for backpacks and camping gear. But the important part is that every single time we perform an action here, there's APIs going on the bottom, under the hood. And our goal here is to actually take this web use case and actually reutilize it as an API test case. So I'm gonna make my order, submit for approval. And if we come over here to my mail, we'll see that I have a order here. I want to make note of this because we have a single order currently. I want to make sure, and it's very important that if you're working with APIs and creating an association with these manual use cases you're doing, that they perform the same action. So now that I have a single order here, I want to make sure that when I run my API test, it does the same thing. So we can stop the recording now. So to bring up a pop-up where I give it a name. So we'll just call this webinar backpacks. Additionally, I can associate this with a work item. So if you're working with something like Jira, with work items, you can actually specify it here. So if you have your story that you're working on as a manual tester, after the fact, you can make sure you have recording going on, and then you can set the work story you were working on the API test case. So now you have an API test that's associated with that work item as well. Create test assets. We can see down here on the left-hand side, we should see a brand new asset created, which we do. So I went from 2 TSDs here to a single one, or two. I went from 1 to 2 here. And if I expand this, we'll see what exactly was captured. So we can see, even though that test wasn't very long, maybe 10 clicks or so, we have quite a few API tests here, or quite a few REST clients. And that's the way API testing normally goes. Normally, it's not a one-to-one between clicks to API calls. There can be quite a few. And this is one of the reasons that makes API test creation so difficult to get started when you don't have a lot of familiarity with the service. The second portion of it has to do with these JSON data banks, which is you're not entirely sure what data is needed for subsequent API calls. And so we can see here, this is something that Smart has done automatically for us, is it went through the traffic and went, okay, these items are actually utilized later in the API call sequence. Let's make extractions for them and then set them aside so we can parameterize those portions later. This allows us to have a much more stable test to make sure it's not so brittle where changing data is going to break your test case, right? Let's say you get a new order number every single time you run your test manually. If your API test doesn't handle that, as well, it's going to break immediately on the next playback. So we have the extractions. If we come over here to, I believe it's one of these, we'll see if we have. Okay, so over in test 3, we're actually making an extraction, and this is not being used until test 41. This is one of the reasons, this is the other reason that API testing is just can be very difficult to get started with. You're not entirely sure where that data is going to be needed, and sometimes it's very far from its original points. So in this case, we have a gap of I think 38 test cases, which is huge, right? If you're looking through a big old traffic file of API tests or APIs that occurred, it's hard to know that something all the way in test 3 or 30 tests beforehand was actually important. So we parameterize this automatically. Additionally, we have an assertion here JSON asserter. This was added automatically for us through smart test templates. So this is something we noticed was important for us to validate after the fact. So we've actually specified this as a test template. Whenever we see this API call, we're actually going to be adding assertions every single time. And this saves us time. And I'll discuss it a bit more when we get back to slides. Now the important part. Let's actually run this and see what the results are. All right, so we have success when we do the execution. Most importantly, if we come back over to Chrome, if we refresh this page, do we see a second order? And we do. So this API test that we've now generated through Smart is performing the exact same actions that we performed with manual testing, which gives us a test that we can then automate and perform playback whenever we need to. All right. So to recap from a high level, we allow users to record traffic between a client and a service where the client is typically UI. Then the smart generators AI builds those models and generates a stateful API test based on the model. Then we go further and allow those models to be enhanced and trained over time. For instance, if the testing team knows a specific API should always have a certain assertion, the model can be trained, as we saw there, so that whenever any member of the team records a new API test scenario that includes that API, the test will be generated with the assertion, saving testers more time with repetitive test setup. The result is a record and replay API testing workflow that's substantially faster than UI testing, where the AI does the hard work for us. Additionally, I said typically a UI here because this workflow isn't constrained to just recording traffic from a UI. We can proxy between two different APIs. So if you're doing microservices, you can actually put a proxy there, record that traffic as well, and do the same thing that we saw with the UI testing.
Before we move on from this topic, one thing I want to point out is many programs, many projects have already really invested or started their automation journey by focusing on the UI layer. So they've invested a lot of time, a lot of energy into writing UI test scripts, adopting frameworks like Selenium, Cypress, Playwright. There's quite a few of them out there. One nice thing about Parasoft's AI capability here with our smart AI test generator is that QA teams can easily transform any existing UI automated test cases that they have into API scenario tests by simply adding a couple commands to their execution scripts so that it talks to the Parasoft side. This works for any web UI test, regardless of the framework. So it really is all about allowing a QA team to rapidly expand their test strategy to include API testing by generating a complementary suite of API test cases. So very powerful at the end of the day when it comes down to an example of AI. Okay, you want to go to the next slide? So we're going to switch over next to discussing the next example of AI we want to cover today, and that is generative AI or LLM-based test generation. So I'm going to turn it over to Ramiro. He's going to walk you through at a high level this workflow, and then we'll dive into the technical presentation.
Thank you, Jamie. What you will see is that leveraging LLM models, a QA tester can actually write test case descriptions in natural language, dictating to the AI engine what test cases should do and the functionality they should validate. The user will then input the prompt with their API service definition file. The AI will analyze the definition file with the user prompt that was provided and begin generating API test scenarios that follow the specs outlined in the prompt. Test cases are then added to SOA test, where they can be executed. Jamie, is there anything you'd like to add here?
Yeah, one thing I want to reiterate is how powerful this is in API first or API led development. While we saw that first demonstration of the top down approach to test creation where we leveraged a web UI traffic recording to generate test cases, often you want to start building out your API test cases early in the application lifecycle before a UI has been created, or maybe your application doesn't have a UI. And when an API is in design, one of the first assets that's created is the service definition file. Now, while leveraging a service definition file to generate API test cases is really not a new capability in the industry, the really exciting element here is that generative AI brings the ability to enable less technical testers to generate these test cases through those natural language prompts describing what that test should do. So while we're seeing here both a acceleration gain on the side of test creation, we also see that API testing is being made to be more approachable for these less technical testers. So Ramiro, you wanna show us how this looks in action?
Absolutely. So for this, we're going to head back over to SOA test. I'm going to close these. And what we're going to do is we're going to create a brand new test suite. We go add new test, give it a name. Head over to REST. And here we provide our service definition file, which was the first part of our requirements. And then we're going to have creation of a test scenario. And here we have the location where we can provide the prompts. We do have example prompts if you want to just throw something in there and see what it comes out with. What's going to become probably most common for users who are using this is that you're going to have your recent prompts. These are the ones you've input in the past. And what you're going to do is once you've had a prompt previously, you can either take it and modify it for a new use case, or you can build out a completely new one if that's necessary. So I have a prompt here I'm going to be utilizing. I'm going to create a new category. So when we were looking at the that demo app earlier, we had backpacks and we have tents. I'm going to create a new category for that. I'm going to add an item to it, verify that the item exists, then delete the item, delete the category, and then verify categories to make sure we're back to our starting point. To do this, we're going to select generate. Okay.
Oops.
Give me 1 second.
This is how you know we're doing a live presentation. All right.
Interesting.
Let's try
Let
that
me
again.
try that one more time. Hopefully it's not down. That would be interesting. All right, looks like we just had a little hiccup on the API call. Okay, so we hit generate. We now have our, this is what the OpenAI has provided back to us as the results for the prompts we provided. So we have post of a new category, item is added to it. We get the item to make sure that it's successfully added. We do some deletes, and then we double check to make sure everything's clean again. One thing to note is if this had been wrong, like if this had not been exactly what I expected, I could click regenerate. It would then let the OpenAI or whatever LLM you're using, this isn't exactly right. This is what you provided us. It's not exactly right. Please regenerate, and it will give you something different to go with. This time was actually completely correct, so I'm not going to do that. But a very simple button to have it retry it. I'm gonna click finish, and that's gonna generate a TST for me.
Hey,
which is our
Ramiro, we
testing
have
area.
a question that makes sense to answer right now. They're asking what LLM models, so what large language models Parasoft supports.
So we have support for OpenAI, and then we have support for Azure OpenAI at the moment.
Hmm. And you guys will be the first to get this information, but we are very close to our software releases coming up for fall. And as a part of that software release, we will be expanding our support. So we do support now custom LLMs. Exciting stuff. Okay.
Exciting. It's even come up semi recently, actually. So
Yeah.
that's good to know. We notice here that we actually have JSON databanks here as well. So it for one gave us a list of different API calls that we should call to fulfill this use case from the prompt. But also Sotas went through and went, okay, it looks like this information and this information are actually needed for subsequent API calls. Let's make sure we extract it. So when we execute this, we're actually feeding it into it and requiring less modifications by the user to make sure these can actually be executed. And then we can run our test. Oh, and that actually occurs right here. So we can see we are parameterizing the category ID that is extracted from test 2. We did run it. It ran successfully. I would go over the demo app to show you, but it deleted it, so we won't be able to see it actually like that. But what I can do is actually come over here, disable this, rerun it with just the 3 test. And now when we come to demo app, if I come to the home, we should see a new category added here. So that's exactly what we see, category name with a description. We didn't really give it a lot of details yet. That's something you can build out in the future. A lot of these tools are going to be used to give you a really strong starting point to then continue your testing. You can then begin to data drive, add more assertions, diff tools, use these to be reference test. All of that is possible with these test scenarios that are being generated through both smart and an LLM integration generation. All right, let's head back over to the slides. I think Jamie,
You want to turn it back on over to me?
yes. So, make presenter.
All right. Perfect. So again, thank you for the demonstration there, Ramiro. So we have now covered the 2 examples of AI applied to test generation. And now we're going to turn our attention on over to our last topic, so managing change. So why focus on managing change? Well, it's estimated that 70 to 80% of software bugs are introduced during the change process. These are numbers coming from studies from IBM and IEEE that seem to back up the estimates. And this really means that when applications changes that go untested or under tested, expose companies to a lot of quality and security risks. So it's very key that we make sure that these changes are being validated as quickly as possible. Application changes can also impact the existing application functionality, leading to regression failures. And overall, this impacts that end user experience. If the software user is not able to use the software due to a new bug that was introduced or a regression failure where existing functionality is suddenly impacted, this can have a huge impact on your brand. We can think about some examples that have been in the news lately, for instance, like CrowdStrike. You want to make sure that any changes that you're doing are going to be validated. So Ramiro's next going to walk us through how test impact analysis, which is an AI ML based capability, optimizes the change management process, enabling teams to focus on application changes in their test cycles so that they can reduce risk. Go ahead, Ramiro.
Sorry about that. I'm muted. Thank you, Jamie. So, what is test impact analysis and what does it do? At a high level, test impact analysis is an AI ML driven capability that optimizes test execution and accelerates testing cycles by helping teams focus their testing efforts and resources on application change. So, how does it work? What starts with mapping what code coverage you're getting for each individual test case that's being executed. Next, we do a code diff from a baseline build when you last ran your full regression test suite. This could be from yesterday, a few days ago, last week, or even the last release. That baseline is completely up to you to decide. And as a result, you're able to calculate the exact set of tests that are impacted by the code that change from that baseline build. And we do this at a method level precision from your code. Jamie, is there anything you'd like to add here?
Um, yeah, thank you for the rundown there, Ramiro. One thing I want to point out where we're talking about test impact analysis, we're talking about it today in the context of API testing, but we also have infused this in our tools throughout the Parasoft platform. So we've infused in our unit testing solutions, as you saw today in our API and integration testing and end-to-end testing. Now, note that it says here, oh, let me click again, any tool. This year, we released new capabilities to support test impact analysis for Java and .NET applications, supporting any automated test framework. So if your problems, one of your challenges might be long test cycles, regression failures, slow change validation processes because you're trying to retest your full application each sprint, you could consider applying a little bit of AI to your test strategy. Keep your existing test cases, your existing test framework. Leveraging something like AI-based test impact analysis is going to help you to focus your test strategy on application changes. Now let's look at what effect test impact analysis has on CI/CD pipelines in the wild. Now here at Parasoft, we like to say we drink our own champagnes. So to say that means at Parasoft, we internally use our own testing tools to ensure our software solutions meet our customer expectations and standards when it comes to quality. So these trend graphs come from one of Parasoft's development teams that was facing scaling challenges. And that was because of the number of test cases that they had. They wanted to accelerate their feedback loop. So on the left, we see a trend graph of a full regression suite for one of our projects internally. It had over 4,000 test cases associated. On the right, we see how many tests were run with each incremental build where test impact analysis was turned on. And we can see is that there's a variable set of tests that were intelligently selected by the AI because they validate those specific code changes in that build. And if you notice the y-axis on the graph on the right, there's a 0 missing. So this team was seeing on average test jobs that contained 50 or 60 or so tests per build, where the full regression had over 4,000. And remember, again, that baseline you compare it against is all really up to you. So this is a great technique for in-sprint testing because not only does it speed up that feedback loop to development, it also reduces the infrastructure burden on running so many test cases in your pipelines. More importantly, it reduces how many tests you need to maintain for a given time period when you're looking at incremental testing. You can really start focusing on maintaining the subset of test cases that are relevant to each incremental testing period, thus significantly helping you on your test automation journey. So quick recap of the benefits of test impact analysis here. This AI feature is designed to help teams to focus their testing efforts and resources on validating new or modified components of the application. In Sprint, the QA team's focus should be on what's new, what has changed. However, easily identifying what has been impacted by changes is challenging and very time consuming to do manually. So test impact analysis really solves that challenge. Often teams don't have a good way to identify the test cases they should focus on each sprint. So they end up needing to retest the entire application. So test impact analysis is saving them time. It empowers them to be more strategic in their efforts. And by validating changes in sprint prior to full regression runs, teams can reduce regression test failures and reduce the risk of untested code or code modifications, breaking existing functionality, impacting the user experience. Now, the last thing I want to talk about briefly here is updating test cases that have been impacted by application change. Again, this is not an AI feature, but it does wrap up our discussion on change management well. While APIs are fairly resilient to change, you will see instances where an API schema change will impact your test cases. And when it comes to looking at API testing solutions, it's really important to look at what capabilities or features the tool has that can help you to minimize the test maintenance burden. And our Parasoft, our answer is what we call our change advisor. QA teams can import into our SOA test solution 2 versions of a service definition file and automatically generate a change template. They can review the template and how SOA test algorithms were able to match up new elements on the new version with existing elements on the old version. So for example, if get ID in V1 maybe became get identifier in V2, the tool is going to connect these two together. Once that change template has been reviewed and approved by the tester, they can then, with just a few clicks, apply it to a full test case or a full test suite and bulk refactor all of those impacted test cases. So really what I want to say here is, coupling this with test impact analysis is giving teams the ability to focus on changes while also reducing the time needed to update their impacted test cases. So when you're looking at testing solutions out there, just keep in mind what is that test maintenance strategy that solution is going to provide you. All right, we're at our wrap up. So please, if you have any questions, pop them into the chat now, into the QA box now. To summarize, how does AI benefit teams looking to adopt API testing? It's really all about increasing test productivity and reducing the technical barriers when it comes down to API testing adoption. AI gives teams the ability to accelerate test creation with both a top-down as well as bottom-up approach, and it increases test thoroughness and consistency. As with more time to test, QA teams can produce more test cases, closing coverage gaps and increasing quality. And it makes it easier for less technical teams to adopt API testing. All of this has this big impact on reducing costs, as API testing provides QA teams with a very scalable and maintainable approach to test automation. Now, as we wrap up and folks get their questions in, I do want to provide you with some additional materials that we recommend in case you'd like to dig deeper into our solutions and platform. First of all, we've got here our brochure for the continuous quality testing platform. Parasoft is unique in the sense that we support testing across the SDLC. So from the very first line of code being written all the way to release, we automate testing across all phases. So I highly recommend checking out that brochure if you'd like to learn a little bit more of how our tools work and how they interconnect. Next, I also recommend checking out our AI ML solution page, as today's presentation focused only on the API testing side. And we do have AI infused in our solutions across the platform. For instance, we enhance our static analysis tools with AI for accelerating defect remediation. And if you're a part of a Java team, I highly recommend checking out our AI capabilities for unit test generation as well. Now, if you're starting to look for solutions to help you to streamline your functional testing, I also recommend looking at what analyst reports say. So we have here linked the 2023 GigaOM report that came out last December, and you can see a comparison of different solutions, get a better feel for what vendors are out there, how they're innovating, and what solutions might be a good fit for you. I do see some questions starting to come into the chat, but last little thing. Next week is the Star West Conference in Anaheim, California, over at Disneyland. If you're going, I hope you'll come on over and say hello. Ramiro and I will both be at the Parasoft booth 30. So if you're at the conference, pop over. Let us know what you thought about this presentation. If you've got any testing challenges, maybe you just want to talk about AI, come on over, let's have a little chat. We'd love to meet you. My colleague Renata Santillan is also going to be hosting a talk on Thursday at Star West. It's on the art of winning leadership support for web accessibility. So if you are there, I hope you'll also attend our little talk we're going to do. And if you are still considering Star West, you haven't yet bought your ticket, we do have there a little promo code that will give you $200 off the ticket price. Finally, again, this was a high-level overview of Parasoft's functional testing solutions focusing on AI and API testing. If you would like to see something more in depth, I highly recommend reaching out to us on our website, requesting a demo. Now, let's dive into some of these questions that we have here. Let's see. All right. Hey, Ramiro, can you see the questions in the chat? Because my controls are being a little finicky on me and not letting me expand it. Wait, no, I just got it. Okay. I want to create data from API and assert in a UI test. How can I use an API response as a parameters, I think it's parameterization value to UI
Yeah.
test.
Yeah, he's looking to, or they're looking to extract information from an API test scenario and then
Hmm.
utilize that for validation within their UI test or to power a UI test. And either way is possible. The first step is to the first step is to create your API test scenario, and then within that same TST file, the same file, you would add a second test suite, and that would be for your UI test. In the API portion, you make sure you add your extractions using JSON databank or XML databank or even text databank, depending on what it is, and then you feed that into your UI test case. So yes, perfectly possible to do that.
Okay, good
If you're
question.
already using the tool, feel free to contact support on at the customer portal, Parasoft customer portal, and ask for help. They can point you to the correct documentation.
We also have the question, is test impact analysis AI done through an LLM model, or through LLM? I can take that one. So test impact analysis is not through a LLM. That is through Parasoft's proprietary AI algorithm. So the same with that smart AI test generation from a traffic recording, that's through our AI algorithms, not the LLM, the large language model. Um, then let's see. Oh, you're welcome. Someone said thank you in the chat. And then let's see, this one's a good one too. My company says we can't use LLM. Can we still use Parasoft AI? So we were very careful about that when it came to our way that we integrated LLM into our tools. All of our LLM integrations are optional. So it doesn't come out of the box integrated. When you adopt Parasoft, typically you'll work with our support teams, or you'll get some professional services to just help you get integrated with the LLM model of your choice. So with that, you don't need to use the LLM side. But keep in mind, a lot of the reasons why companies say we're afraid of using or we don't want to use an LLM model is because it's a cloud-based LLM. So, you don't want to put your code out into the cloud. You don't want to expose sensitive information, anything like that, sensitive data. So the fact that we're now going to be supporting these custom LLMs means that it can be on-prem. So I would actually go back to your organization, maybe ask them if they're exploring custom LLMs. I know a lot of companies are exploring that right now. Some much more advanced than others. But there is a chance that they are, and that would mean that you could integrate with a custom LLM. Let's see. Could you tell us how we could obtain your tool, especially the API testing tool, pricing, et cetera? So our pricing, we have a separate pricing team here at Parasoft. So you would have to have a discussion with our account management and sales team about, how many team members you're looking to support, all that information, and then they can get you a customized quote. As far as obtaining our tools, it's pretty easy. You would just reach on out to us. You can use that demo request right there and fill out a request. And one of our team members will reach on out to you. We'll have a discussion with you about what your testing requirements are, and then how you want to proceed. So do you want to see a more in-depth technical demo? Do you want to do an evaluation where you get the tool in hand, get it on-prem, actually use the tool a little bit and see how it fits your needs? All of that can be addressed, through that sales team. So if you start the process of just requesting a demo, they'll help you get pricing, they'll help you get set up with a technical demo. And then if you do want to go into an evaluation, they'll also help support an evaluation on-prem. All right. Are there any other questions? Is there any updates happening in code we need to change scenario from there onward or from starting? Oh, if there's any updates happening in the code, I think it's, do we need to change scenarios from there onwards or from starting? I'm not sure on that one. I think I'm going to
Um,
follow up. Do you know what they're asking?
I can take a crack at it. I think,
Okay.
well, maybe we can follow up as well. But so if there's if the application changes do we need to make brand new scenarios using smart or using LLM? And it's going to depend on how exactly it changed. If the API itself has been modified, we do have a tool. If you have a service definition file, let's say you created this from the LLM integration, you have a service definition file. If there's a new service definition file for the new version of the application, we actually have a tool within SOATest that allows you to do changes between service definition files. We didn't have time to get into it today, but that does exist, and it's part of the base model of SOATest, so it is available to everyone. The other the other possibility is that you created this one smart, which does not require a service definition file, so that option isn't available. In that case, I would ask, is the changes that happened to the application, were they at the API level or the UI level? The reason I ask this question is because UI changes all the time. You make modifications, you move things around, and it really does change the way your UI test scenarios work. On the other hand, this rarely makes a modification to the actual API calls that are made or the way the API calls speak to each other. So in that case, you don't have to make any changes to your smart use cases. If they does make a change to the API workflow or the APIs themselves have changed though, and you don't have a service definition file, you would have to make new recordings from the start there. So it depends on what type of changes were made to the application that are going to affect how you move forward with your test cases that are existing already and the ones you're going to be creating in the future.
All
Hopefully
right.
that answers your question, but we'll follow up with you later.
Okay, unfortunately, that is all the time we have for questions. If there are any other questions we haven't addressed, I think we've caught all of them, but just in case we missed any, we'll be sure to follow up with you in email. And again, if you'd like to talk a little bit further, feel free to reach on out to us to request a demo. You're also welcome to find Ramiro and I on LinkedIn as well. Always happy to talk about test strategy. And again, if you're going to Star West, stop by booth 30, come over and say hello to us. Thank you guys again for your time today. We really appreciate it. We appreciate all the great questions as well. Ramiro, anything you'd add before we say goodbye?
No, thank you for having me. Have a good day,
All
everyone.
right, perfect. Thank you. Have a good one, everybody. Have a good rest of your week. Bye bye.
Bye bye.